given g of x equals the square root of 2 minus x, find g composite g of x and its domain. Step 1, let's find the formula. G of x. Replace the inner g of x with the definition of g of x. It's the square root of 2 minus x. Now, using the same definition, evaluate g for the value square root 2 minus x. You get a big square root, we're using this definition, of 2 minus little square root of 2 minus x. Step 2, find the domain of this formula. It's the formula for g composite g, right? And if we're trying to, we should actually put a box around this because this is the answer for g composite g of x. And we forgot to box it. Okay, so what is the domain of this thing? Well, there are two restrictions. There's the outer square root restriction and the inner square root restriction. And we have to choose x values that simultaneously satisfies both of those restrictions. So we're going to take the intersection of the two restrictions. The outer, the big square root restriction is that the radicand, everything under the big square root, must be greater than or equal to 0. And it's because it's an even index root in here. It's an invisible 2 in the hook. Okay, so take the radicand, the stuff under the radical sign, 2 minus the square root of 2 minus x, has to be greater than or equal to 0. And intersect that with the restriction for the little radical, which says its radicand, 2 minus x, must be greater than or equal to 0. Now let's solve each of these inequalities for x. Let's work on the left side first. First, move the 2 over by subtracting. Then divide or multiply both sides by a -1, which flips the direction of the inequality sign, and it gets rid of both the negatives. Now we want to get rid of the radicals, so we square both sides, and then we move the 2 to the other side by subtracting. Now we have to get rid of this negative by multiplying both sides by a -1, which flips the direction of the inequality again, and we get x is greater than or equal to -2. Now let's do a similar thing for the radicand restriction for the inner little radical. The radicand 2 minus x must be greater than or equal to 0. So you move the 2 to the other side, it becomes -2, then you divide or multiply both sides by a -1, you get x is less than or equal, it switches the direction to 2. So now we have two simple inequalities, and we have to find the intersection of these two. So we are going to go up and look at, let's see, do we have more down here? What's going on down here? Let's see, step 1, step 2. From here, I see, we move to the right. And we take the first inequality and we graph it. We take the second inequality and graph it with the intersection. Line up the -2's, line up the 2. What is the intersection going to equal? Line up the -2, line up the 2. Check each of the areas to the left of -2, in the middle between -2 and 2, to the right of 2. In the first area to the left of -2, there is no shading in the intersection because we do not have shading simultaneously in both of the sets above. Between -2 and 2, yes, we have shading on both of the sets, so it will be shaded in the intersection. To the right, no, there's no shading in the second inequality, so it will not be included in the intersection. What about the number -2? It's included up here in the first set. It's included in the second set because it shades directly through it. So yes, it will be included with a boxy bracket in the intersection. And similarly for +2, it's included. So the domain for this big hunky formula that we got for this new composite function is, in interval notation, everything from -2 to 2 with boxy brackets on each edge. And finally, step 3, the domain of the inner function g intersected with the domain of the formula is going to give us, oh my goodness. All right, this was just so complicated. I can't imagine giving you a problem this hard on the test. We just got really bogged down in finding the domain of this formula. It took a long time to get that, but this is the result right here. So step 3 was to take the intersection between the domain of the formula with the domain of the inner function. That's what that is. And that gives us -2 to 2. So that is a domain of G composite G.